Hello dear judge, my name is Yasemin Akbuyuk.
And my name is Marko Pejov. We come from Yahya Kemal College, Skopje, and today we'll be presenting about the cleaning properties of vinegars.
So our project is cleaning water from heavy metals with natural vinegars. As we all know, eliminating heavy metal pollutants from wastewater is a serious problem nowadays. The presence of heavy metals in wastewater and groundwater is a serious potential danger to all ecosystems and all living beings. Concerning human health, heavy metals have been related with the incidence of cancer, liver and kidney failures, and so on. It is important to find a solution to this issue, and we attempted in doing so by using natural resources. In this project, we have examined the potential effects of different vinegars from different regions of Turkey on the removal of heavy metals from wastewater and groundwater. We prepared water samples containing different concentrations of 4 heavy metals: copper, zinc, manganese, and lead in their cationic form, and simulated water samples that were polluted to different extents. We monitored adding different volumes of vinegars on the prepared samples, and we determined the concentrations of copper, manganese, lead, and zinc upon suitable pre-treatment and incubation for at least 24 hours. For this purpose, the atomic emission spectrometry technique has been used. Considering that the issue of the presence of heavy metals in wastewater and groundwater is very serious, many methods have often been used for their elimination. But these methods often involve equipment and they are rather expensive. But however, our method is cheaper and natural, so this makes our method unique. Now my teammate is going to explain the details in the structure of the project and the results we have achieved.
So now I'll continue to briefly explain the experimental procedure. First we have prepared a series of 4 different heavy metals in deionized water, and these heavy metals have a pro-analogous quality, which basically means that they are very pure. And in this form, in their cationic form, these heavy metals are bioavailable, which means that they are toxic to humans and animals both. And we have added 20 milliliters from each of these heavy metals to 18 different laboratory beakers. And in this way, we hope to achieve a simulation of pollution in certain large body areas, large water areas. Afterwards, we have added a series of different vinegars originating from Turkey in different quantities to each laboratory beakers. Their volumes range from 2.5 milliliters, 5 milliliters, and all the way to 7.5 milliliters. And afterwards, these samples were subject to heavy stirring for about 30 minutes. And afterwards, to ensure that there are no solid particles left from the vinegar, we have filtrated the samples. Afterwards, these samples were left to incubate for about 48 hours or 2 days. Afterwards, to determine if the experiment has actually succeeded, we have used the ICP technique. I'm now going to briefly explain the ICP technique. So this technique basically uses argon at a very high temperature to change the state of matter of the samples to plasma. And in this state of matter, the electrons of its constituent parts get excited. And using some of these properties, we can essentially determine each of the concentrations of the constituent parts. And now I'll briefly explain an equation that we use to determine the removal rate of all of the constituent parts. So we take the ending quantity, and from that we subtract the beginning quantity divided by the beginning quantity. And if we multiply that by 100, we get the removal rate of the vinegars. And here on the graph we can see that it actually worked very well. Mostly have a removal rate of about 99%, which means that our analysis showed that it clearly works. And now I'll also say that doing more thorough analysis, we can also see that different types of vinegars work better for different types of heavy metals. And now I'm going to explain why this actually works. So these vinegars actually contain microorganisms, mostly bacteria, which in order to satisfy their physiological needs, they essentially use up these heavy metals. And also another thing that we have observed in this experiment is that if we add more vinegar, that doesn't mean better results. Why? Because if we change the optimal level of the pH level of the sample, the microorganisms don't work as they should and the efficiency goes down. And this method is very good because it works very well, it's cheap, and it can be used in large quantities to help places all around the world.
So this was all about our project. I hope you enjoyed it. Thank you for your attention and greetings from North Macedonia.